This is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will prove that a certain map is bijective. So in the previous video, we went through what bijective means, and we also looked at a few maps and used reason and logic to determine whether or not they would be bijective. But now we're going to formally prove that a map is bijective. So we're not just going to use reason and logic. So what is a linear map? So it's a map I'm going to call F induced by y equals mx plus c. So this is a linear map. It takes x, a real number, times by m, and adds c to get another real number. So this is the map F. So here, m would not be equal to 0. Otherwise, this really wouldn't be a map. So then, we're going to show that this is bijective. So remember the definition of bijective was that it is both injective and surjective. So I'm going to prove that this map is injective, then prove it is surjective. So let's get started. So a map F is injective if FA equals FB implies A equals B. So this is the formal definition of injective. So what it's saying is if you have two elements in the codomain, so these will be elements that have been mapped to in the codomain, if they're the same, then the elements which were mapped to them must also be the same, because that's the definition of injective. We can't have elements that are the same in the codomain being mapped to by different elements from the domain. That's what injective means. So it turns out this will not be hard at all to prove. So what would f of a be? Well, what it means is I've just taken some number a and applied the map. So f of a will be m times a plus c. Similarly, f of b will be applying the map to b. So if these two are equal, so if fa equals fb, then that means I have this equals this. But I can just subtract c from both sides and I get ma equals mb. But I can divide each side by m because m was not equal to 0. Otherwise, it wouldn't really be a map. So ma divided by m just gives me a, and on the other side, I get b. So if fa equals fb, then a equals b. So if two elements in the codomain are the same, then they must have been mapped to by the same element from the domain. So that proves that it's injective. Now let's look at proving it's surjective. So I want to prove that this map is also surjective. So this is the proper definition of surjective. What it's saying for this case is that for each y value, there exists an x value that can be mapped to get that y value. So essentially what it's saying is if you tell me the y value is 10, that there is an x value that I can start with that will get it to 10. So I have my equation y equals mx plus c, right? So if I tell you the y value, how would you find the x value that you needed to start with? Well, that's very simple. You subtract c from both sides. You subtract c from both sides and divide by m. So y minus c divided by m equals x. So the thing about this is, though, that that is a real number, because real numbers are closed under subtraction and division, as long as I'm not dividing by 0. But m doesn't equal 0, so I'm not dividing by 0. So this will be a real number. And there will only be one real number. Of course, if I take any y value, subtract a number, a real number, and then divide by a real number that's not 0, there's only one possible solution. but there is actually a solution, and that solution is a real number. So what I'm saying is, if I tell you the y value for this map, then there will always be an x value that you start with to get that map, and that x value will be a real number, so it will be a part of the set. So therefore, this map is surjective. So what I've actually proved is that this map is injective and it's also surjective, and that is the precise definition of bijective. So my proof is done. I have proved that this linear map is bijective. Alright, I hope you've enjoyed this video. This has been the luckiest maths teacher in the world. Have a great day.